we have, let me come back to where we, page number 21, na? Yes. So then we have a PIR2 register. In that, again, they are explaining it, they are explaining it in page number 28, but actually it won't be exactly 28. Let us go and see. So they say bit not is CCP2 interrupt flag. Capture compare mode 2. There are two things we have, no? Capture compare. So if the second one is done, they will get this black bit to set to 1, 2 and 1. That means the second bit and third bits are not implemented. Then BCLIF. Bus collision has occurred in SSP. Synchronous serial port. If there is a bus collision, this particular bit will be set to 1. EEF, E from write operation interrupt flag. That means the write operation has completed. If you try to write EEPROM, EEPROM is something different from flash. So you can write each memory location one by one. When you write each memory EEPROM, you have to get some sort of confirmation, right? Your write has been successful. If it is successful, EIF flag will be set to 1. Right. Then there is a comparator in interrupt flag. The comparator input has changed, the comparator input has not changed. So it depends on the, if there is a change in the input, automatically CMIF flag will be set to 1. That you can use it to ensure that whether the comparison works or not. So this is the, as these are also peripherals, we are grouping them into peripheral interrupt register 2. Makes sense? So we have done with peripheral interrupt. Then timer 1 L, timer 1 H. Timer not, no, it is only 1 byte timer, that is 8-bit timer. So its lifetime delay that you can create using the timer will be very minimal, but you need more delay. To make more delay, you can go for timer 1. Timer 1 has 16 bits, 2 bytes. 2 bytes to hold the periods, the delay that you want to have for timer 1, right? As this is an 8-bit controller, they divided that 16 bits into 2. Timer 1L, timer 1H, because we cannot store all 16-bit in a single location, because this is an 8-bit controller. The data memory is 8-bit in size, right? That's why they divide that into 2. Timer 1 low, timer 1 high, like that. Got it now? Understood? Why they have timer on L, timer on H?
Yeah, yes, I'm sorry. For one is for L.
Yeah.
More than 1 byte, we used to have timer 1, and it is segregated into
Into 2,
lower 1.
because it is more than 8 bits. If that is the case, we have to use 2 memory location in 8-bit 8-bit microcontroller. That's why.
Yeah.
Then timer 1 control register. I told one thing in the very beginning. So you are giving some clock signal to microcontroller, clock source. From oscillator, we supply some frequency. For this particular controller that we are working with, going to have 20 megahertz clock. If we have a 20 megahertz clock pulse, means this 16 bits will be consumed in a second. Not in 1 second, in microsecond and millisecond itself, because the frequency is very high right now. Even this 2 byte register for timer period will not sufficient. So we cannot create a enough delay. Then what they used to do means they won't supply 20 megahertz clock that is supplied to controller to timer as well. Timer is a circuitry which is inside the microcontroller. That circuitry will get a lesser clock than operating clock, so that we can have much delay. Do you understand what I mean? So the operating clock of the microcontroller is higher than the operating clock of timer. So timer will be slower than microcontroller. Okay, how to make the timer slow? For that, they have two register. Timer, clock, prescale register, 2 bits actually. Prescale register, timer, clock, prescale not, timer, clock, prescale 1. What this will do, let us explore. So it is in 57 data told no. So let me go to 57. T1 gone. This is timer not. Yes. So what they will do, they use those 2 bits to make it. I think they will using this prescaler, they will scale down the operating clock so that 8 times slower than the. If you set these 2 bits to 1, 1, that means 2 bits becomes 1, so it becomes a 1, 1. When it is 1, 1, if the operating clock is 20 megahertz, your timer clock will be 20 megahertz divided by 8. When you set that to 1, 0, it will become timer 20 megahertz divided by 4. If it is 1, 20 megahertz by 2, which is 10 megahertz. Like that, that operating clock of timer can be slowed down, or we can make it slow by using prescale bits. That is what the use of this. When we want to use your timer not or oscillator to supply an external clock, you can set timer 1 oscillator enable bit to 1. Then timer 1 SYNC active low means this pin will be low. Timer 1 external clock input synchronization control bit. When the TM R1 CS is equal to 1, do not synchronize external clock input. 0 means synchronize external clock input. Like that we can control. Timer 1 CS. Timer 1 clock source, where we are going to get the clock. Otherwise, to count the time for that clock, for the timer circuitry, are we going to use internal clock of microcontroller, or we want to get a clock from outside? If you set this bit to 1, they will look for external clock. If you set this bit to 0, the internal clock will become F oscillated divided by 4. So clock source, when by default, when they supply a clock to timer, even though your prescale register values are 0, 0, if we are operating at 20 megahertz, we are giving timer only 5 megahertz. That 5 megahertz further divided into different level, like 5 megahertz divided by 8, 5 divided, only then that delay is possible, because the operating frequency is too huge now. So that's what they are saying. If you make this bit to 0, you mean that the timer is going to receive 4 times less than, that means F oscillator divided by 4. Your operating clock frequency divided by 4 is the operating clock of timer. From there, if you are using prescale, you can further reduce the operating frequency. Right. Then there should be some bit to start the timer, to make the timer to run, no? For that they use timer 1 on bit. When this bit is set to 1, timer will be started to count. It will start counting it. Got it now? So here they are saying this we will discuss because we have a clear detail about this timer, how they are operating. In that discussion we can discuss. As of now, let us understand the register and then status bits that we have in those registers. Then we have a timer 2 module register. As we have timer 1 control, then timer 2 module register. So if you look at the timer 1 module register, it is just an 8 bit only. That means 1 byte timer. Right. Then timer 2 control register. Here we have a very lengthy prescaler for timer 2 output prescale. So if you go there, you can understand it. Let us go and see what they are really mean by that. It is explained in the page 61, right? Timer 2. So it is having a post scaler, right? Because it is having only 1 byte in size. If that is the case, frequently it will expire. But in order to get output, which is very slower than what the actually is, for that they use this 1 by 16 prescaler, which is totally 4 bits, I believe, if I'm not wrong. So here they have an explanation for that. Output prescaling, timer which is output, right? The timer output which is coming from timer 2. Here there is no prescaling. Post scaling happens. So they divide it by 16 times. Right. Whatever that 20 megahertz divided by 16 will be your output timer 2 output frequency. Right. Then to turn on the timer 2, you have to use this bit. And then timer 2 clock prescale select bit also there. So you can 0 0 means 1, 0 1 means 4. After 1, whatever, if you make make your MSB bit to 1, that means this bit to 1, which means that it will, then they will divide 20 megahertz divided by 16. Already 20 megahertz divided by 5 is given to divided by 4. Yeah, divided by 4 is given to timer. From there we divide. If we set that to 1 it is divided further 16 times slower, and then if you use a post scale again, that is divided by further 16 times, so that I believe this will be more appropriate to create a more slow delayed output. Right. The timer 2 will be more appropriate, though it has a only 8-bit period register. It has we can create much delay using this one. Synchronous serial port receive buffer register, and then we have SSP con. Right. So for this we will discuss tomorrow.